I have the privilege of having Mr. Prith Banerjee here. He is currently the CTO at ANSYS. And welcome, Prith.
Thank you. Thank you, Rajeev. Very, very good morning to you and everybody else.
Yes, thank you. And where are you calling in from today, Prith?
I'm calling from the ANSYS office of San Jose, California.
Awesome, wonderful. Prith, we're just going to dive this into this podcast here. Just tell us about yourself. Who are you? Why are you there? And what do you do?
Sure. So I am Chief Technology Officer at ANSYS. ANSYS is a modeling and simulation company. We help our customers in building most amazing products. And my role as CTO is to advise the company about the long-term technology strategy, right? Where is simulation headed? Where is ANSYS headed? Where should ANSYS invest in terms of new technologies? And I've been doing this for the last 6 years. Prior to ANSYS, I have spent some time in academia. I spent about 20 years in academia. I was involved with a couple of startups. And I've also worked in several large companies like Hewlett Packard, ABB, and Schneider Electric.
Awesome. So I love the word simulation. In technology, we use a lot of simulation. Virtual machine is, goes back to long time ago when all of this started. Tell us in real world, where do we see your product? Is it like simulating a car race or simulating crashes?
So actually, I'm glad you asked that question, right? So simulation is used by designers across different industries, right? In designing and simulating amazing products. So for example, we serve customers in the automotive industry, and there we are helping people design cars, right? And so when you say design cars, right, there is the OEM, like a Ford or a General Motors or a BMW, who will use our simulation. But these simulation tools will also be used by the tier one suppliers that supply parts to Ford and GM, for example, Aptiv, Bosch, Continental. It will also be used by the tier two suppliers like Infineon and NXP that makes those ECU chips that go inside those parts that go inside the car. So the entire supply chain of the automotive industry uses our simulation tools. Or let's look at aerospace industry, right? So the OEMs are like Boeing and Airbus, right? They will use our simulation tools to figure out how that airplane will fly. But not only that, the tier one suppliers, the engine suppliers, the General Electric, Rolls-Royce, Pratt Whitney, they use our simulation tools to simulate those engines. And then the software platform companies like Honeywell, right, that use to control all the things on the airplane, they are also using our simulation. Next vertical, say energy, industrials, right? All the energy companies, the Texacos and the Chevrons of the world, right, as they're sort of extracting oil, they use our products. The ABBs and Schneider Electrics of the world that make power and automation equipment, they use our products. Next vertical, high-tech industry, right? So all the electronic chip companies, the sort of Intel and AMD and Broadcom and Qualcomm and all the cloud companies, the Microsoft, Azure and Amazon, AWS, they are our customers. Final sort of things, healthcare, and it's like companies like Medtronic and Johnson & Johnson that make medical device equipment, or companies like pharma companies like Bayer and Novo Nordisk and so on, right, that make pharma drugs. So we have more than 15,000 customers across these 5 verticals, and they're all using it to design the most amazing products.
That's insightful. I had no idea that there was a need and someone is fulfilling this need. So walk us through, how did you build this technology? What does your team look like? I mean, sounds like there's a lot of developers. Tell us how many transactions you're dealing with. Give us the complexity and how you're solving this problem.
Yeah, so the way we solve the problem is we look at the world around us, which is governed by the laws of physics, right? So when you look at this glass that I'm holding here, right, I can say I want to apply this much pressure, and when I apply this pressure, the cup bends. This physics of structures is governed by what are called second order partial differential equations called Euler equations, or There is coffee inside this, right, which is governed by fluid flow, that is governed by Navier-Stokes equations, or this electronic thing that we are talking to each other, right, is governed by Maxwell's laws, electromagnetics equation. So the world around us is governed by Newton's law, Maxwell's law, Navier-Stokes equations, and so on. And we take those fundamental differential equations and we solve it numerically. That is what we do, right? So ANSYS got started more than 50 years ago by John Swanson, who used to work at Westinghouse Corporation in Pittsburgh. And he says, well, I want to solve this structural problem using a technique called finite element analysis. So that was the beginning of ANSYS. And then over the years, we have moved into different physics like fluids physics and electromagnetics physics and so on, right? Through organic R&D and through acquisitions. And today we are a company of about 6,500 employees. We have about $2.1 billion in revenue. We have more than 15,000 customers. We have more than 10,000 transactions of sort of software sales that we do to our customers across these 5 verticals. And this software is sold sort of full perpetual license or lease or on the cloud.
So talk to me about the technical implementation. How does that look without, of course, we don't want any secrets, but talk to me about the transaction volume. Talk to me in terms of response time. Like I drive an electric car and it has, full service driving capability and it's able to think as soon as it sees an object and the response time is incredible. Talk to me how you deal with such complexities in tech.
Yes. So when I said we will solve a physics problem, like for example, you are sitting in a car, right? And the car can crash. And so where automotive customers do is they'll put a dummy inside the car and they'll bang the car at 70 miles per hour, hit a thing, right? So, but when you do that crash testing, that car gets destroyed, right? So what if you could do that purely through simulation virtually, right?
Yep.
Without actually destroying the car. That's where we come in, right? Now a problem as complicated as car crash, right, is so complicated, right? You would need maybe 1 million finite elements to solve that problem. And this problem may take just one sort of second of simulation, physical simulation, physical thing, right, would require maybe 20,000 hours of compute time on a really sort of fantastic computer, right, to solve it accurately. So our simulations take a long time to run just to look at sort of 1 millisecond of real time that you're trying to deal with, right?
Interesting.
And so in order to get the sort of faster response times, we do look at things like using high performance computing, HPC, and sort of shared memory multiprocessing, message passing, GPUs, all the stuff that you hear from NVIDIA and Jensen, all those Blackwell GPUs. So we are using all of that technology to accelerate our simulation. We also use AI machine learning to accelerate our simulation. So essentially, these simulations are very accurate, but take tens of thousands of hours to run for really complex designs. And we use high performance computing or cloud or AI machine learning technology to speed things up so that the designer will be able to evaluate multiple options and design the most optimal product.
That's powerful. So you touched on AI ML, and that's my next question. Tell me how you're using AI ML or deep learning or supervised or unsupervised learning in this context.
So AIML is used in simulation for two broad areas. One is to accelerate simulation, right? So as I mentioned, these simulations oftentimes take 1,000 hours to run, 10,000 hours to run. So the first use of AI is to train an AI model with maybe 1,000 different designs, right? Here is this design with this input condition, this boundary condition. For this input, here is the output, right? For this input output, you train the AI model, this sort of thousands of neural networks, right? All the weights of those neurons, right? What should those weights be? And you do this over maybe 10,000 different designs. The neural network learns the designs. And next time you give it a new design, Instead of running the full numerical methods that taking sort of tens of thousands of hours to run, it would run in a matter of minutes. And that's called AI. And we have a tool that we have recently launched called Sim AI that can literally accelerate simulation by factors of 100 or 1,000. So that's
Okay.
accelerating simulation. The other way is to make simulation easier to use because, Rajiv, these tools are super accurate. They are really, really good, but they are very hard to use, right? You almost need to have a PhD in electrical engineering. I have a PhD in electrical engineering from University of Illinois, right? To
I like
use
that.
to use our HFSS tool for electromagnetics, right? You almost need a PhD from University of Illinois to actually know what settings to use to get the best quality and
Uh,
speed and convergence, right? So it is not that easy to use, right? The most advanced users know how to use it. So the role of AI is to sit and watch what an advanced user is doing, right? You have this problem. Oh, it's a multiple input, multiple output antenna problem. For this, you have to use tau meshing or tetrahedral meshing and so on, or you have to do it with this way. So an AI will watch what a smart engineer is doing and then basically sort of do it automatically for this thing. And so we have just announced an AI tool called ANSYS GPT, which is based on generative AI technologies to make the tools easier to use.
that's interesting. I used to joke around that you need a PhD to do this. Finally, I know that there is one problem where you truly need a PhD to do it. Talk to me about the generative AI product that you just launched. What is that?
Yeah, so the again, it's a sequence of things that we are working on. So basically, with Gen AI, as you know, right, you can ask a question, right? Hey, summarize, tell me about Prith Banerjee, right? You will go through and find out all kinds of information on Prith Banerjee and give a saying, hey, what does Prith Banerjee do at this, right? In
Hmm.
100 words or less. So what a Gen AI does is it scrapes through all kinds of information in the world. You ask a question and it'll give you an answer. So the first product that we have launched of this sort of Gen AI chat GPT technology is called ANSYS GPT, which says we have, as I said, more than 15,000 customers, right? And they're always asking questions to our application engineers. Hey, I'm trying to run HFSS for this problem. What settings should I use? And then the
Uh,
ACE engineer responds back saying, oh, you should set it this way. Then another question comes in, oh, trying to run Fluent. What should I use? They say, oh, you should do it this way. So there's a question that comes in and there's a response from the engineer. So you have taken over the last sort of 15, 20 years, right? All the questions, all the answers, put them in chat GPT, right? And it's our own on-prem version, not the one on the cloud, right? And using that, we have trained ANSYS GPT to answer very accurately, right? All those RAG models and so on and so forth, right? With no hallucination to give very, very accurate responses, right? And it's a 24-hour, 24/7 chatbot, right? Which is super intelligent, but based on all the questions and answers that are coming from different customers to our ACE engineers. And that's
so
sort of the first thing that we have launched called ANSYS GPT.
so very contextual on-prem, and it's interesting to build that model. Did you use any third-party apps or you built it from scratch?
No, we built it from scratch. Well, we used the OpenAI's uh, sort of chat GPT, but not OpenAI's. We have a partnership with Microsoft. So the Microsoft version, I guess
Okay.
the Copilot, right, is what we use to build this. But we trained the model and so on, but we didn't use any other third party. We just took sort of OpenAI's chat GPT, but the Microsoft version, Copilot, and used it to 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 create this thing. But so this is the first version, and then using this, what we are doing is, so this tool today, you get a question in English and then you respond in English, right, to a human, right? But what if you could go the extra mile and actually do the settings of the tools? Because in the question answer, it
Yes.
says, oh, you should use tetrahedral meshing. Well, it turns out that you can actually go into the setting, right, using Python script to actually do the setting of this thing to run the whole thing automatically. So we have actually shown, this is not a product yet, but in terms of some early work that we have demoed to our customers to say, hey, you give it a question in English, and it's almost like, okay, Siri, turn on the alarm, right? You say, okay, Fluent, run this, and it will run Fluent for you based on your
Interesting.
English language specification.
So
So
you're
that's
taking
ease of use.
so you're taking prompt engineering to workflow now, right? You're extending that. That's
Yeah,
really
exactly.
cool.
Very
Now
cool.
I know there's a lot of innovation you're doing. You're seeing a lot of innovation in the industry. Talk to me about what innovation you wish you had today that doesn't exist.
Well, the ultimate innovation is, I mean, designers want to design a car, right? And so they would like to take a specification of a car, like, hey, I want to design electric vehicle, which will go from 0 to 60 in 1 second and have a range of 1,000 miles. I mean, if I could build that, right, I would be the next to the next
Yep.
Tesla, right? But you doing that. So what happens is an engineer will go in. Okay, I need to have 0 to 60 in 1 second. So I need this huge motor, right? It's a permanent magnet motor or an AC motor, DC motor, whatever, right? And look at, do I need a 100 horsepower motor or 1,000 horsepower motor, and figure it out is the size of it, right? Then they say, okay, so because of the motor which weighs maybe 1,000 kilograms, right? And then you will have four passengers, each of whom will weigh say 100 kilograms, right? Now you put it all together to have a range of this kind of miles, right? I need a huge battery, right? Well, so that's the size of the battery. So once you put that gigantic motor and the gigantic battery, your inertia becomes so large that it doesn't go from 0 to 60, right? So then
I
you
love
say,
that.
oh, I now have to iterate. I don't think I can have that big a battery, make the size of the battery wrong. So this is how designers actually design products, right? They'll take a specification, break it down into subsystems, right? What should the motor be? Based on the motor, what should the powertrain be? Based on that, what should the battery be? And based on the battery, what should the power electronics be? And they're just doing these different parts to do it
I got you.
independently. And then I start writing the software to drive the motor and this thing and so on. And it takes 7 years, right? This is why it takes 7 years for a completely new car to come in the automotive industry, right? What if, so the innovation is, what if you could take a specification of this car that you want, right? And just push button, everything will be done for you, right? And which is sort of what we call the field of digital engineering, right? Sort of synthesis of what I call cyber physical systems. It's a hardware software combined system coming out, right? With a push of a button.
Interesting.
It doesn't exist today, but
Yeah.
that is something we are working on.
Very cool. Very cool. Now, um, I'm curious, you have a fairly large team. How do you keep tabs on making sure projects are running smoothly, making sure everyone is being productive and the right technology is being built, and simple things like coding standards are being met, security is in place? Just maybe spend a minute on talking about what does your org culture look like, what's your organization look like, and how do you keep, things before they're out of control?
So So as I mentioned, I mean, ANSYS today has about 6,500 employees, right? We're, as I said, we're a $2 billion company. Of those 6,500 employees, about 2,500 are R&D developers, right? They are the ones who are writing code, right? And in addition, we have about 1,500 application engineers. These are the people in the field that help customers with those things, right? So the 2,500 R&D developers and the 1,500 are the 4,000 engineers, many of the PhDs that I would call are the intellectual capital of ANSYS. So in my role as CTO, I'm responsible for these. They don't direct report to me, but it's like I'm the cheerleader of this 4,000 person engineering team, right? And so what we have done is we have taken these individuals and we have approximately, broadly speaking, 10 sort of product groups. Like, so there's a product group around structures, we have a product group around fluids, there's a product group around electromagnetics and semiconductors and so on, right? So these sort of 2,500 R&D developers across 10 product groups, that's how these R&D groups are organized, right? Then what we do is, in order to make sure that these people have the right intellectual capability and the learnings and so on, we have broken down sort of our areas into 5 technology pillars, right? And those are things that are organized and orchestrated by the CTO office. So the first pillar is numerical methods, right? I mean, in our solvers, right, we have to use the latest numerical methods around finite element, finite volume, finite difference, time domain, different methods, multi-domain, multi-scale, multi-physics simulations, and so on, all the geometry and meshing. So we have a center of excellence in these areas, led by a couple of the smartest sort of ANSYS fellows, and they do a regular meeting about, okay, making sure the different people working on numerical methods across these 10 different product groups are all aligned and they're using the latest technology. If there's some latest stuff that is happening on sparse matrix solvers, they immediately bring in and make sure that everybody is aware of it. So the latest technologies out there, right, coming from academia or in conferences are immediately being used in different tools.
That's
Second
awesome.
pillar is in sort of high performance computing, right? The latest technology in shared memory, message passing, this, that, GPU, oh, there is this thing coming from NVIDIA, the Blackwell machine, or the AMD's MI300, or here is this CUDA DSS sparse solver coming in, right? So the HPC Center of Excellence is making sure that the latest HPC technology is leveraged across ANSYS. Third pillar, AI, machine learning, right? The latest work about RAG models of this and large language models, right? Whatever you're doing, right? Everybody's aware of it, and we are using AI across different products. Fourth one is around cloud and platform, right? I mean, what should you do in terms of working on the cloud for Azure cloud or AWS cloud, cloud marketplace, this thing, access, and so on, software as a service. And the fifth one is digital engineering. This is what I kind of talk to you about, right? Taking system level specifications and automatically able to generate different things called digital twins and so on. So the way we coordinate our technology strategy and the product strategy is making sure different products have product areas, right? Oh, we are going to have this feature in 25 R1 or whatever. What kind of technologies do we do? So there is a very nice interlock between the products strategy. These are the features we want and what kind of technologies we'll need in order to do this. And of course, we do the right things with respect to security and so on and so forth as we are building these products.
Really insightful. Now, you came from academia and you are in corporate world now, and I saw that you are also an author of a book. Talk to me, why did you have to write that book and what are you trying to tell, you know, the audience?
Thank you, Raju, for saying this. So I recently wrote a book called Innovation Factory, right? And the reason I wrote the book was I've been fortunate to have spent some sort of 20 years of my life in academia. I was a professor at the University of Illinois Urbana-Champaign. I was at Northwestern. I was a dean of engineering at University of Illinois Chicago. So I saw, right, how academics, professors, and graduate students actually discover new stuff, right? So, and we are writing publications and papers and all kinds of stuff, right? But the academia is looking at really futuristic, innovative things, right? But they don't actually make products, right? They are discovering new knowledge. And then I spent a few years working on two startups, right, which took ideas from my university labs and actually built really innovative products out of it. My startups were Excel Chip and Banerjee. The last 15 years, I've worked at large companies like Hewlett Packard. I ran HP Labs worldwide. I was CTO at ABB, CTO at Schneider, and now the last 6 years, I'm CTO at ANSYS. So these large companies are, I mean, do these things, right? They have not just a single product, they have a whole portfolio of product, right? And and what I noticed is that large companies do a great job in the incremental innovation, right? I work for HP, right? HP is making, say, laptops or servers or printers, right? So the next version of the printer, they will absolutely nail it, right? Because the printer exists. They're looking at the feedback from customers. They're looking at competition and say, in the next year, my laser printer should have these features. They absolutely nail that very well. With respect adjacencies, right? So I work for ABB. I have some transformers working at 110 volts in the US. I want to go to develop a transformer for India going to 220 volts, slightly different frequency. That also they nail, right? So Horizon 2 adjacencies, they absolutely do a good job. What they mostly struggle with is the disruptive innovation, right? How does a company like Apple, right, which is making MacBooks and so on, right, all of a sudden invent this fantastic thing called an iPhone or an iPad? So it takes, I mean, companies like Apple or Amazon, right, to come up with this truly disruptive innovation, right? So how can large companies routinely invent new things, disruptive new things in brand new markets? That's what I write about in my book on Innovation Factory. And sort of the guidance that I give is you have to do through a combination of organic R&D in sort of the office of the CTO, but not just do it organically, do partnerships, reach out to various universities, fund research at universities, as well as work with various startups and bring all that what is called open innovation, ideas from outside, inside your company, and try to build these really, really innovative products, disrupt the market.
That's incredible. Now, a lot of companies like this, they end up having like lab or skunk work generally, and a lot of times they make investment into smaller startups. Is that also kind of part of that innovation factory theme?
That is exactly what I mean. So basically, I mean, I have multiple chapters in the book, but I do talk about this. Yes, absolutely. So you have to have a lab, right? And so when I used to run HP labs, but the lab, if they only do the invention part, right, but not the product, right, and then the product market fit in terms of the actual going and trying to sell it, right? So what happens is in many of the large companies, right, you may be doing some very, very innovative product, but if your sales force, the sales force is designed to sell your current set of products, right? You invent something new, right? They would not know how to sell it. Give you an example. When I was at HP Labs, right? HP sold process servers, printers, and software, right? So at HP Labs, we invented this new thing called Memristor, which is a non-volatile memory, right? Very, very innovative stuff. Now, HP does not sell memory, right? We use memory, we buy memory, right? But here is this very innovative memory that we invented, right? We did not know how to sell. So
Mhm.
the point I say in my book is if you are going to really do disruptive innovation and R&D, you also need to give that group a sales and marketing arm, right? Your own
True.
salespeople who can sell that product, just like if you were a
Yeah.
startup, you would have your R&D and salespeople who would sell those things. Unless you do that, all the wonderful R&D innovation that will happen in your sort of lab will just go to waste. And so this is why, I mean, you have organizations like Bell Labs and Microsoft Research and so on, right? They have oftentimes created the most innovative ideas like Xerox PARC. People talk about Xerox PARC inventing the mouse, right? But Xerox did not know how to take that GUI and sell it, right? It took
Exactly.
Steve Jobs to come to Xerox PARC and say, hey, this I could sell it, and then took that technology and so on. So all I say in my book is, if you are going to be serious about disruptive innovation, sponsor their R&D, but also have that incubation, right? That sales marketing arm to sell that product and grow that business to a certain level before you hand it off as a real business unit.
So really, R&D is not just R&D lab, but it's a business unit and it has an R&D inside it. Amazing.
Absolutely.
Love this
Yeah.
idea. All right.
And the
Uh,
point is that you should, as part of it, don't try to invent everything yourself. Even if you are an R&D organization inside a large company, right? If you find a startup that is doing something relevant, try to bring that startup's technology into it. Don't think about not inventing, oh my God, I didn't think of it, I will not get a credit. Your management should give you the same credit whether you invented it yourself or you scouted the best technology and brought that in, because you are responsible for bringing that new technology to your customers in a beautiful product.
that is super insightful, Prith. I love this conversation and I love the details you're providing. Just quick rapid fire questions before we wrap up. Any book you're reading right now that you're in love with besides your own book?
I'm actually reading Walter Isaacson's book on Elon Musk, right? I mean, Elon Musk is ultimate innovator, right? And again, everybody knows about Elon Musk, but
Yes.
that book goes into detail as to how, as an innovator, right, he was able to drive all those people, right, to create SpaceX and Tesla and all those the Boring companies and so on, right? I mean, this guy is absolute genius, right? I mean, he's not the most easy person to work with, but how a person like Elon has been able to drive innovation, right? Again, I'm sure you've read Walter Isaacson's
Yes,
book on Steve Jobs also. These
amazing
two
book.
books are just phenomenal books, right? It
Yes.
really motivates me to think about how true innovators really innovate.
Favorite apps on your phone?
Ah,
Name
I
two.
mean, I just very boring things. I mean, I listen to a lot of music, so I use Pandora a lot. So yeah, Pandora and Spotify and so on. So those are, I'm really into Indian classical music, so I listen to music all the time.
Okay, no, same here. Any favorite movie or show that you've been recently watching? Or
Actually, I'll tell you, I watched the movie Current Wars, which
Current
is this
Wars?
whole sort of conflict between alternating current and direct current, the fight between Edison, right, who was pushing for DC current, and Westinghouse and Tesla, who are pushing for AC current, and
I love
the
that. That's
conflict
truly
between
geeky,
those.
man.
So that is fantastic. So that was one, and the other one is Ford versus Ferrari, right?
Yes, I
And
heard
these
good
are two
reviews about
movies
that.
I watched on the airplane, right? I mean, you go on these long international flights to Europe, right? But these two, both movies are phenomenal, right? One obviously goes back to the 1890s and how those innovators were trying to take two completely different technologies, and but it goes into actually the business things and the technology things side, how they went, and then Ford versus Ferrari, right? Oh, Ford is this sort of boring company and Ferrari is this fast company, but how they were able to kind of out innovate each other. Both are excellent examples of technology combined with business, which is sort of the kind of thing that I absolutely enjoy watching.
Favorite vacation spot? Anything, any place that you will want to go back whenever you have time
We
off?
This is actually kind of crazy. We love London and we love Paris. In fact, we are going to London in 3 weeks, and
Why do you
so
like London or Paris? Name a few things.
these are big cities, and my wife and I both love going to big cities and enjoying the sort of the cuisine, right? I mean, go to the best restaurants in those places, the best staying in the best hotels, best places, and then taking short trips. Right. So when I'm going to London, my wife and I, she likes to go to the place called Cotswolds, right, which is like 2 3 hours off London, but we'll just take a drive there, go into various restaurants and so on, do some shopping, come back. So it's that's kind of interesting. And the same thing we love Paris. These are two of the largest, most culturally rich sort of cities, and then sort of going to restaurants, seeing shows, and so on. So
Awesome. And
and I
then
will, yeah.
last question. Give us one or two tips. How do you manage your day? How do you deal with uncertainty? What are some of the productivity tips that you have for people to, you're like, I wish I could share this to the public there and say, use these, it will help you.
The only tip I would give is about work-life balance, right? I mean, I have a phenomenally exciting role, right? And if I wanted to, I could not just work 40 hours a week, I could work 900 hours a week, right? I mean, if the work is very addictive and you keep on wanting to do it and so on, right? But if I did that, after a while, right, my brain cells would not be able to generate the new ideas, right? So the brain cells actually need to rest. So in order to have the maximum productivity, if you only do work, it is not a good idea. So the way I do the work-life balance is, I mean, I love music. I love Indian classical music. I play one instrument called the sitar, which I know you will know, but many of your
Yep.
podcast, your audience may not know. It's an instrument that Ravi Shankar used to play, and so I love playing the sitar. I have played it for the last 30 years, and I'm reasonably good at it. But that playing the sitar, right? So when I go home and I just take out the sitar and play it, right? And that really calms me down and so on. So, and again, of course, I try to not bring home a lot of work. When I am home, I'm spending time with my wife, my son, and so on. So I try to do that relaxation, which is very important. Right?
It
So
is.
that work-life balance is so important for your work part and your life part. That is
It's in,
something that I would really like
it's
your audience to fully appreciate.
I appreciate that. It's interesting now that a lot of us work from home. it's not coming back home from work. Work is everywhere. And it's interesting, you have phone and you have Teams and your email everywhere. So it's good that you're able to cut off and able to focus on what's most important and kind of take a break. But I love that
I
if you
do
just
not have my phone near me when I am having dinner. I do not, right? And my wife said, "Oh, your phone is ringing." I said, "Let it ring." When there's dinner time, there is personal time, family time, you don't want to be interrupted, right?
I'm gonna
And
I'm
so
gonna
these
share
are
that with
things
my
that
kids.
yeah, just like when you are driving, right? You're not supposed to text on the phone, and
Exactly.
people are always doing this. So you need to, anyway, these are standard things that everybody knows, but I actually practice what I teach.
I appreciate that, Prith. Thank you so much for being here,
Thank
and
you. Thank you.
really loved your background and what you're doing with simulation technology. Thank you.
Thank you. Thank you. Bye-bye.